Good morning, geometry students. This is Miss Luden coming at you, and I have left a little video lesson for you. So you should have a pink packet in front of you, and it should say Unit 7, Part 2 in front of you. This is a continuation of the green packet, which was Chapter 7, Part 1. So we are going to start, this is called Topic 5 because Topics 1 through 4 were covered in the green packet, and now we're on to Topic 5. So this pink packet is all about what's called trigonometry. And so this year in trigonometry, what we're going to be studying is right triangle trigonometry. And that's the study of the relationships between the acute angles and sides of a right triangle. So you should write in acute angles and the sides of right triangles. Okay, so we're going to start with an intro activity. And yes, you could just wait and copy down what I'm saying, or you could really think about this. So I want you to examine the triangles below. Are they congruent, similar, or neither? So remember what congruent means. It means same size and same shape. Similar, remember what that means. It just means same shape. Or are they neither, congruent or similar? So take a look. What are you thinking? Hopefully you can answer, oh, those triangles are definitely similar to one another. Remember, we could have said they're similar by the angle-angle similarity postulate. They all have a 31-degree angle and a right angle. So they're the same shape. All of the angles are going to be the same. They're different sizes, but the same shape. Okay? So now what I want you to do is examine the sides. The first triangle has a vertical leg of 3 and a horizontal leg of 5. The second triangle has a vertical leg of 9 and a horizontal leg of 15. And the third has a vertical leg of 6 and a horizontal leg of 10. Well, I'm telling you this last triangle has a horizontal leg of 50. What's x? Can you take a guess? So maybe you were able to kind of use a pattern, okay? Did anybody get 30? If you did, give yourself a pat on the back. If you didn't, well, let's think about how we could have gotten that. All of these triangles are similar, which means the angles are all the same and the sides are proportional. So if I kind of compared 3 to 5 in this triangle, well, that's the same as 9 to 15 in this triangle. So I'm just doing vertical leg to horizontal leg, and that's equal to 6 to 10. And that's going to be equal to whatever x is to 50. So you could either cross multiply, there's all sorts of ways that you could go ahead and find x. Okay? Okay, so let's look at this summary. In a right triangle, the ratio of the leg opposite to a 31-degree angle. So let's talk about what that is. Opposite to the 31-degree angle would mean the side that's opposite, that's completely on the other side of the triangle to that 31-degree angle. Compared to the leg adjacent to it. So the adjacent leg would be the leg that's touching the 31-degree angle. And in all of these cases, what does that ratio work out to be? Well, it's about 3 to 5. Okay? This is called the tangent ratio, T-A-N-G-E-N-T. And how we write this is the tangent of 31 degrees equals 3 to 5. So that's how we write that. Let's take a look at the next one. So what I would really urge you to do is I am asking you to find y in this triangle. So all of these triangles are similar once again. I would urge you, pause the video right now and try to figure out what y is. So press pause and try to figure out what y is. Hopefully you were able to notice that 9 to 10
Emily Wyatt, please dial extension 5502. Emily Wyatt, please dial extension 5502.
is equal to 90 to 100. Well, that's the same as 18 to 20. And all of those are going to be the same as 27 to y. So maybe you cross-multiplied, maybe you did all sorts of stuff. But hopefully you got that y is 30. All of these ratios are going to be equal to one another. So once again, in a right triangle, the ratio of the leg opposite to the 42-degree angle, so that's that 9 and the 90 and the 18 and the 27, to the leg adjacent to the right triangle, that's going to be the 10 or the 100 or the 20 or the y. Every single time, that ratio is going to reduce to 9/10. And this is called the tangent ratio. And how we write this is tan, short for tangent, 42 degrees. That's going to equal 9/10. That opposite leg over the adjacent leg. So, we can take a look and we can find the tangent of other angles. Well, in this triangle, here's the 23-degree angle. Well, we know that the tangent ratio, it's saying what is the tangent of 23? Well, the tangent ratio is going to be the ratio of the leg opposite to the 23 to the leg adjacent to the 23. So we know the tangent of 23 is going to be equal to 21, that opposite leg, over 50. I would urge you to pause the video right now and try the next three. Okay, hopefully with tangent of 50, you wrote down the opposite leg, which is the 12, over the adjacent leg, which is 10. Now we always do like to reduce this, so both 12 and 10 are divisible by 2, so I'm going to reduce this to 6 to 5. For the tangent of 70, hopefully you wrote down the opposite leg. So the leg on the opposite side of the triangle is 25. The leg adjacent is 9, which can't be reduced. And the tangent of 31, well, the leg opposite to the 31 is 6. The leg adjacent to the 31 is to 10. Now we do reduce this. They're both divisible by 2, so we're going to reduce this to 3/5. So, what's going to become important in this chapter is labeling the sides with respect to a certain angle. So angle A is right here. Well, I'm going to label the leg that's on the clear opposite side of that angle. I'm going to label it OPP, opposite leg. I'm going to be abbreviating this with the letter O, and I'll just put a circle around it. Now I'm going to label the leg that's adjacent to A. So the leg that's adjacent to A is this leg right here that's touching the A. And I'm going to be calling that A. Now what do we call this side that's opposite the right angle? Well, maybe you remember that this side is the hypotenuse. And I'm really sorry my handwriting's so messy on this thing. It's hard to write on this. I'm going to be kind of abbreviating this with an H with a circle around it. So now we have to do the same thing in the other triangle, except we're labeling the sides with respect to angle B. So clear on the opposite side of B, that's going to be the opposite leg. I'll just abbreviate it an O with a circle around it. The leg adjacent to B is going to be that leg that's touching B. So I'm going to call that A for adjacent leg. And then we know that this side opposite the right angle, that's called the hypotenuse. So I'm going to be calling that h. So as we said before, the tangent ratio is the ratio of the opposite leg over the adjacent leg. So the tangent of angle A, well, for angle A, BC is the opposite leg, and AC is the adjacent leg. How's that going to change for the tangent of angle B? Well, with angle B, AC is the opposite leg, and BC is the adjacent leg. These problems are going to ask you to find the tangent of different angles. So this says the tangent of angle Z. So first of all, I'm going to find angle Z, and then I'm going to label all of the legs, all of the sides, opposite leg, adjacent leg, and hypotenuse. Well, I know that the 21, that's going to be the opposite leg, so I'm going to label it with an O. The 28, that's going to be the adjacent leg. I'm going to label it with A. And the 35, that's going to be the hypotenuse. I'm going to label that with H. I know the tangent ratio is the opposite leg over the adjacent leg. So the O over the A, opposite leg over adjacent leg. So I'm going to write the tangent of angle Z as 21 over 28. Now, that reduces. Both of those numbers are divisible by 7. So if I divide both numbers by 7, or you can just use your calculator, it reduces to 3/4. Let's do one more together, then I would encourage you to pause the video and try a couple on your own. So now it's asking me to find the tangent of angle C. The first thing I'm going to do is label the sides, opposite, adjacent, and hypotenuse. Well, the 27 is the opposite leg. The 36 is the adjacent leg, and the 45 is the hypotenuse. I know the tangent ratio, that's the opposite leg over the adjacent leg, so it's going to be 27 over 36. Well, that reduces. Either put it into your calculator or realize that both of those numbers are divisible by 9, and that reduces to 3/4. So, I would strongly urge you press pause right now, and try the remaining 4 on your own. Okay, hopefully for tangent of A, you realize that the opposite leg was 21 and the adjacent leg was 20. 29 is our hypotenuse. We're not going to use that quite yet. So this is going to be 21 over 20. For the tangent of angle C, well, hopefully you realize that the 40 was the opposite, the 30 was the adjacent, and the 50 is the hypotenuse. So the tangent of angle C is going to be the opposite, which is 40, over the adjacent, which is 30, and that's going to reduce to 4/3. Tangent of angle X, hopefully you realize that 32 is the opposite, 24 is the adjacent, 40 is the hypotenuse. So the tangent ratio is going to be that opposite leg, which is 32, over the adjacent leg, which is 24. And that's going to reduce to 4/3. Tangent of X. Okay.